Pismo. So to give you an idea of Pismo, if you're not familiar, we're a relatively small community, 55 miles of sewer main, 525 fire hydrants, 10 public restrooms, 1 police station, 3 baseball fields, 200 trash cans. But really what we're going to focus on is our water infrastructure and the water infrastructure in general. So when you work in water and actually in public works in general, when things are right, the public is completely blind to you. You are invisible. They don't even know you exist. Everything's just great. But when things go wrong, people really get upset and you are the center of attention and they want to nail you to a stake and burn you. So it's kind of like, you know, if you're doing your job well, no one knows about it. And when you mess something up, no matter how small, everybody knows about it and they usually get pretty upset. So as far as operation and maintenance goes, we'll look at reservoirs. The distribution system consisting of pipelines, booster stations, and valves is mainly what we'll talk about. Looking at reservoirs, it's really important that you have an inspection program. Here at Pismo, we dive our tanks every 7 to 10 years. And why do you do that? You don't want to be in this situation, especially, you know, this is a rural location. If you're in an urban location, you end up causing flooding and property damage, and you end up on the 5 o'clock news, which nobody wants to do. So how do you inspect reservoirs? I said we dive ours, so that's exactly what you do. You have a certified diver. The one that we use is a registered engineer as well. He suits up, he gets sprayed off with bleach, and he jumps into the reservoir and inspects it. Then he provides a report with pictures on the condition of the inside and the outside of the reservoir. And then we take that information and we go out to bid for a project that usually consists of mitigating corrosion on the exterior and coating the exterior, and then cleaning and often coating the interior of the reservoir. At the city of Pismo, we have 2 concrete reservoirs and all the rest are steel. And I bring that up because one of the things that's really important, especially with a steel reservoir, is cathodic protection. So cathodic protection is a way of controlling corrosion of the surface. And what it does is it makes the reservoir the cathode of an electrochemical cell. And you do that by connecting it to a metal that's more easily corroded, a sacrificial metal that acts as an anode. And then you have an electrolyte between the anode and the cathode, which is the water inside of the reservoir. And typically we'll use zinc, aluminum, or magnesium as the sacrificial metal to protect the reservoir. Without cathodic protection, you can end up with a lot of corrosion. In fact, one of our reservoirs didn't have cathodic protection and the supports inside are pretty much gone. And we're currently in the final design. We'll go out to bid probably in the spring to completely replace the reservoir. So here's an example. This is the bottom of a metal ship. And you can see right here, they have attached a bar of zinc to the bottom of the hull to act as the cathodic protection and prevent the hull from corroding. Another form of maintenance or kind of operations of the reservoir is mixing. Inside a reservoir, you'll get thermal stratification of the water. As the sun beats down on the top of the reservoir, it heats the water and the water will separate into layers by temperature. And what you'll see is a drop in chlorine residual, which obviously is not a good thing. So there's ways to mitigate this, very simple ways, usually with a mixer. This is a jet mixer. There's a side mount mixer and a stand mixer that you can employ inside of your reservoir to keep the water mixed up and make sure that you have proper chlorine residual. As far as maintenance of the pipes go, the big thing that we do here in Pismo is we flush our dead ends, and this is mostly for water quality, not necessarily for the pipe itself. You'll notice here that the operator who's flushing this line through the fire hydrant, which is in many cases how we do it as well, there's a diffuser box to diffuse the water so it doesn't come out in a high pressure stream. And then also we'll throw in a dechlor tab to dechlorinate the water, because the water is safe to drink, but it's not safe to discharge to the environment. And so we need to dechlorinate it. It's important that you exercise your valves. In the olden days, it was done by hand. Many municipalities, including Pismo, has a valve turner where it'll exercise the valve. We go out and we try to hit every valve at least once a year, and we'll open and close it 3 to 6 times. And then we also replace old valves, and we usually do that and replace our water lines when we do street projects. Because there's nothing more embarrassing than doing a street project and paving your streets and then having to come back and rip it up because a water valve failed. You know, one of the example here of why it's important to exercise your valves, and it also ties back to that third slide or whatever it was of when things go wrong. When we were doing our Shell Beach Streetscape project, we replaced our water line. We upgraded it to a 16-inch line to provide better flows. And when the crews went out to shut off the water, we had a number of valves. There was actually 4 of them throughout the project that for whatever reason weren't exercised properly and they wouldn't close. So we closed the valve. It's not closed all the way. The guys, the contractor, I'm not going to tell you names, thought, well, we can still replace the line anyways. They tried to replace the line and do the tie-in and they couldn't. So now they have to go to the next valve down the street and shut it off. Well, when we shut off water, we put out door hangers and we notify everybody, your water will be off on Tuesday, March 16th at 2 o'clock, and it should be about an hour and a half, and everybody knows. And if you set the public up and you set their expectations, they can usually live with it. But when you shut their water off in a kind of a quasi-emergency situation like that, and they have no notice, you get people coming out of their houses in bathrobes with shampoo in their hair, and you get people coming out of their houses wondering what's going on, that we're making dinner, and they really are truly upset. So it's really important that you exercise your valves and keep them in good working order. Looking at booster stations, City of Pismo, we have 8, and there's quite a bit that goes into maintaining the booster stations as far as pump maintenance, maintenance of the motors, and then all the electronical equipment that goes along with it, the SCADA system, and all the pressure transducers and everything like that, to make sure that it runs as needed when needed. And then our guys about every 10 years will go and they'll repaint everything to help protect it from corrosion from the elements. Looking at water supply, I'll share with you our water supply portfolio. We have 3 sources. 27% of it is groundwater, 34% is from Lake Lopez, and 39% from state water. We did sell some of our state water to a third party. So instead of 1,240 acre feet that the county recognizes, we have 1,140 acre feet of state water. Now, I talked to you at the very beginning, at the intro, about water planning and having it be difficult. State water and groundwater are both follow a calendar year, where Lopez follows the Lopez water year, which runs from April to March. There's this chart I used to make for my city council, and they really loved it, and I really didn't. And what I didn't like about it is that if you look at this, and let me, I thought there was a laser pointer here. Maybe not. Anyways, oh, you know what? There is right here. So if you look at, okay, in July, how much water do we have? Well, in July, we're midway through the state water year. We're at the beginning of the Lopez water year, and it's hard to say exactly how much water we have. When I generated this report, I said, okay, our remaining entitlements is 2,145. But that was in August. And if you look at when state water runs out for the year and Lopez runs out, it's not at the same time. So do we really have 2,145 acre feet, or do we not? Because at the end of the state water year, what happens to that leftover water that we did or didn't use? It becomes really difficult to convey to the council exactly how much water we do have. So I actually did away with this chart. It kind of got the idea across, but most of them, it confused them more than it helped them, even though they're the ones that asked for it. Looking at the state water project, if you're unfamiliar, The sort of official beginning is here in Oroville. There's rivers that feed the Oroville, Lake Oroville and the Oroville Dam. And then you can see the major infrastructure spans pretty much the whole state. This map here shows where the reservoirs are as of March 11th. And you can see here that the blue number is the percent of capacity and the red number is the percent of historical average. So of significance to the Central Coast and us here in Pismo is San Luis Reservoir. And you can see it's a 56% capacity and 65% of its historical average. We'll talk a little bit more about San Luis Reservoir later. And then these pictures show some state water infrastructure, an aqueduct, and you can really see how long and vast it is. And another thing to note is it's actually quite vulnerable. The State Water Project provides drinking water for much of the state, and it's just an open aqueduct. And then I threw these pictures in here. This is the Oroville spillway that experienced some failures a few years ago. Just kind of throw them in there. So as far as state water goes, most state water contractors or subcontractors have what's called a Table A allocation. So for the city of Pismo, the county recognizes 1,240 acre feet. We did sell 100 acre feet to a third party, so we have 1,140 acre feet. And then you can buy what's called drought buffer. So we do have drought buffer in the amount of 1,240 acre feet. And drought buffer helps to improve the reliability of state water. It can only be delivered when deliveries are less than 100%. And I'll show you how that works here in a minute. And then it also increases the amount of water that you can store. So when deliveries are at 100%, the city of Pismo gets 1,140 acre feet. It's actually 1,240, but there's that 100 off the top that we sold. And then at a 50% delivery, we get 50% of our Table A plus 50% of our drought buffer. So we end up with 1,190 acre feet. So you can see how the drought buffer really helps to improve the reliability of your water and your water delivery. One thing to note is in no case may our deliveries be more than our Table A. So the drought buffer can only make up to a full allocation of our Table A allocation. So another example at 35% delivery, we'd end up with 399 acre feet of Table A, 434 of drought buffer for a total delivery of 833 acre feet. So you can really see how that improves the reliability. So why is that important? This table looks back to 2004 and shows you the state water deliveries. Every year around November, December timeframe, the Department of Water Resources will announce what the deliveries will be for the following year. And then that initial allocation usually gets adjusted a couple times throughout the year until they settle on a final allocation. Currently for this year, we're looking at a 10% delivery. Looking at this table, you'll notice that there was a low delivery of 5% in 2014 and a high of 100% in 2006. And the average initial allocation is 24% with a final average allocation of 52. So you can see that while state water is really beneficial in that it's geographically diverse, it can be completely bone dry here on the Central Coast, but if it's raining up in Northern California, you know, the State Water Project will have a healthy delivery and will be okay. It's good in that sense, but you can see that there's a wide fluctuation in the deliveries, and that makes it hard for water planning. You can store state water, and it's a little confusing to some on how that works out, but the way there's equations that you follow. If deliveries are between 0 and 50%, you can store 25% of the available water. So your available water is your Table A plus your drought buffer. So right now our deliveries are at 10%. So we can store 25% of our available water. So if you take our Table A plus our drought buffer, 10% of that, that's our available water. And then you can store 25% of that. For deliveries between 51 and 74%, it's 25% plus 1% for every percentage point over 50. So if deliveries are say 30%, then it would be We can store 25 plus 1% for every percentage point over 50. Sorry, so if delivery were 55, it would be 25 plus another 5, so it would be 30% of the available water. And if deliveries are over 75%, you can store 50% of your available water. So where is that water stored? It's stored in San Luis Reservoir, which is a reason why San Luis Reservoir is so significant to us. One of the problems with storage in San Luis is we have zero local control. It's a little bit difficult to get the water delivered, not extremely, but there are some hoops to jump through with the county. The county's the contractor. But more importantly, when San Luis Reservoir spills, we lose our stored water. San Luis Reservoir is an off-stream reservoir. There's no streams that feed it. There is a small watershed, but most of the water in San Luis Reservoir is piped there through the State Water Project. And most of the spills that we see are from moving water through the Delta. There's real constraints on moving water through the Delta, mostly environmental constraints and dealing with endangered species. And so when there's a window to move water through the Delta, depending on how the other reservoirs are looking, DWR will pump a lot of water through the Delta, and that causes spills in San Luis, which means we lose all of our stored state water. Lake Lopez, I'm sure many of you are familiar with Lake Lopez and have played in Lake Lopez. It does supply drinking water for what's referred to as the Zone 3 agencies. It's owned and operated by the San Luis Obispo Flood Control and Water Conservation District Zone 3 for short, which is Arroyo Grande, Grover Beach, Pismo Beach, Oceana Community Services District, and the County Service Area 12. So these are the allocations of each agency. And what's of particular importance is the percentage. And the reason for that is when we don't use all of our water in a given year from Lopez, so we have 892 acre feet. And let's say that at the end of the year, we had 100 acre feet left over. That water goes into a surplus water pool. And the way that it works is that each agency is entitled to the water in the pool by their ownership percentage of Lopez. So if the city of Pismo saves 100 acre feet of water, the city of Arroyo Grande is now entitled to 50% of that surplus. We only get 19.7 acre feet of the 100. Grover Beach could have access to 17.7 acre feet of the 100. The OCSD, just under 7%, and CSA 12, County Service Area 12, 5.4%. Another caveat of surplus water is you have to use it the following year. So in addition to only getting 20% of that water, or said another way, of losing 80% of our saved water, we have to use it the following year if we want it. And then if it's not, it just reverts back to district water. So that makes it difficult for us to really want to save and conserve Lake Lopez, which is a shame because it is a local resource. It is a shared resource, but we're disincentivized by our contract to save and protect that resource. We did develop a low-level reservoir response plan in 2013 when we really hit that beginning of the major drought. We developed this, and there's two criteria to enter. One, the County Board of Supervisors has to declare a drought emergency with respect to Zone 3, and two, the lake has to drop below 20,000 acre feet. There's some prescribed cutbacks as far as deliveries go. The key component of the low reservoir response plan is that agencies retain 100% of their surplus water, and that water carries over every year with evaporation losses until we exit the low level reservoir response plan. So there are some cutbacks though. So at 20,000 acre feet, we establish storage rights. At 15,000 acre feet, we take a 10% cut to municipal deliveries. 10,000 acre feet, a 20% cut. At 5,000 acre feet, a 35% cut. And 4,000 acre feet is just about dead pool of the reservoir, and we can't pump water out of it anymore. The water won't flow out of it anymore. It can be pumped, but it's dirty and murky. So we take 100% reduction at that elevation. When we developed the LRP, we started saying to ourselves, well, if we're developing storage rights for an emergency, why don't we work towards that long term? So the Zone 3 agencies, along with the County of San Luis Obispo, have been working on contract revisions. I've explained to you how long-term water planning is difficult because of the fact we don't retain 100% of our stored water, and we have to use it the next year. We lose our saved water. So the benefits of the contract revisions is that it'll allow for storage rights. It'll allow us to better use all of our water in a holistic manner. There's a provision where we can store state water there, and then we can take full advantage of Central Coast Blue, which I'll provide you on information about that in just a minute here. Our final source of water is the Santa Maria Groundwater Basin. It is an adjudicated basin. The management group that manages it is the NCMA, or the Northern Cities Management Area. That was a group that was set up by the courts. There's also the Napomo Mesa Management Area and the Santa Maria Valley Management Area. Those are all dictated by the courts. For the NCMA, we actually have allotments that we're allowed to pump that are in the adjudication. The other areas don't have those specific numbers, but we do. But long before the adjudication, Arroyo Grande, Grover, Pismo, and the OCSD worked very cooperatively to protect the groundwater basin. And we actually came up with these numbers through what we refer to as the gentleman's agreement that was later adopted into the stipulation to protect the groundwater basin to prevent saltwater intrusion. We are the canary in the coal mine, so to speak. If there is saltwater intrusion, it's these agencies that are going to feel it and really be damaged. Folks on the Mesa and down in Santa Maria, they have a buffer before the saltwater gets to them. There was constituents consistent with saltwater intrusion detected in the basin in 2009. And the NCMA has developed what we refer to as the Deep Well Index to monitor the health of the Santa Maria groundwater basin. We established a threshold of 7.5 feet elevation, which is right here. And you can see this chart goes back to the mid to late 60s, and it has the Deep Well Index. It's a combination of 3 monitoring wells. And you can see that here, starting in the mid 2000s, that we dropped below that 7.5 foot threshold. And we were there for 3 years below that trigger level. And you'll see here that the chloride levels spiked, which is kind of an indicator of saltwater intrusion. So all the agencies really drew back on their pumping. We're currently pumping about 30% of those numbers that I showed you previously to ensure that we don't have saltwater intrusion. And you can see here, this shows the Deep Well Index going back to 2015 quarterly measurements. And you can see we've done a really good job of keeping the groundwater basin levels above this threshold. So these are the monitoring wells here that saw those constituents consistent with saltwater intrusion. And I'll point out to you that the green dots here, these are Pismo's wells. This is Oceano's wells. You can see how close they were to those detection points. Oceano, blue is Grover, and orange is Arroyo Grande. Finally, as far as water production goes, I'll just share with you, this is going back 20 years. So from 2001 to 2020, the city of Pismo's water production by source. And really what I want to highlight to you is how well our community has done at water conservation. There was some water conservation mandates that were put into place and reporting requirements that go along with that. But you can see that this column here that I've highlighted is going back comparing to our 2013 production. That's the benchmark for water conservation targets. And our community's really done a good job. Our council has developed some water conservation programs, including the first waterless urinal mandate that I could find on record, as well as a mandate for ½ gallon per minute aerators on all publicly accessible restrooms, including hotel rooms. And then we also have water conservation rebate programs. So hats off to our community. So Central Coast Blue. Some of you may know about Central Coast Blue, some of you may not. I'll give you a brief update on Central Coast Blue. But Central Coast Blue is a regional groundwater sustainability project, a recycled water project that takes effluent from the city of Pismo Beach wastewater treatment plant in phase 1 and purifies it and injects it into the groundwater basin. Central Coast Blue will provide sustainable water supplies, and it can meet approximately 30% of the existing water demand by the partner agencies. It puts to beneficial use recycled water, reducing ocean discharge by 77%. So it's a huge amount of water that's currently being discharged to the ocean that'll be recovered, purified, and injected into the groundwater basin. So we have these 5 agencies: the city of Pismo Beach, the South San Luis Obispo County Sanitary District. I will just call them the district from now on. The district provides wastewater services to Grover Beach, Oceano, and Arroyo Grande, but working together for lasting water independence. So the project started, the historic drought really highlighted vulnerabilities in the city of Pismo Beach and our neighboring agencies' water supply portfolios, which I shared with you with State Water, Lopez Water, and Groundwater. The project started as a Pismo Beach project. We did a recycled water facilities planning study that said the best, supplemental water source. We looked at recycled water. We looked at raising the Lopez spillway. We looked at several different sources of water, and it really pointed to recycled water. And as we started working on the project and designing the project, the district also did a recycled water facilities planning study, and to nobody's surprise, came up with the same conclusion. And so we figured that it would be better to do one regional project, since the project is about $38 million, than 2 separate projects that are going to cost about $38 million a piece. So really, it was the right idea, the right thing to do for all communities to come together and do one project. Central Coast Blue will leverage a water source that's wasted to the ocean, and it'll protect the groundwater basin and improve our water supply reliability. So looking at this, this is the city of Pismo Beach treatment train here, and disposal to the ocean. And Central Coast Blue will add the advanced water treatment, and I'll go over these processes later. There'll still be a disposal to the ocean in a brine, and then the water will be injected into the groundwater basin, and then it'll have contact time in the water table, drawn through our existing potable water wells, municipal wells, and delivered to the community. So currently, the state of California does not have regulations to allow direct potable reuse, which is why we need to do indirect potable, where it's injected to the groundwater basin and then extracted later. So our partner agencies, if you're not familiar with the area, looking at the attendee list, most of you are, but Pismo, Grover Beach, the Sand District, Grover, and the Oceano Community Services District. You can see where they're all located, but it makes sense. We share the groundwater basin, we share in Lake Lopez. It makes sense to share in Central Coast Blue. Interagency collaboration has really been key to the project's success. We're all small agencies with small budgets. So the EIR for this project was funded 50-50 by the city of Pismo and by the district. So, and again, the district is funded by the ratepayers of Arroyo Grande, Grover Beach, and Oceano. So all 4 of the agencies really participated in the EIR. We developed a groundwater model that looks at the entire Santa Maria groundwater basin from its northernmost reaches all the way to the Santa Maria riverbed. And it developed this water model, and that was funded by a Prop 1 grant. So the water board, the county participated through Zone 3, the district, and then also the city of Pismo. And then as far as preliminary engineering goes, phase 1 of the project will treat and inject effluent from the city of Pismo Beach wastewater treatment plant. And then phase 2, if deemed necessary and feasible, will treat and inject water from the district's wastewater treatment plant, and that'll be funded by Grover Beach and Arroyo Grande, 50-50. External funding has really opened up new opportunities. We did successfully receive a Prop 1 grant. It was for just under $1.5 million. And the water board worked with us, and they were really intrigued by Central Coast Blue and they really like the idea of it. They've seen other successful projects, Monterey, Oxnard, Orange County. So they really wanted to support us, and they said, if you can increase your matching funds for the project, we'll increase the grant award to $2 million. And so we did increase our matching funds. They did increase the grant. And what this is paid for is a test injection well. It allowed us to update our monitoring plan, our basin level response plan, leaching study, and offshore aerial geophysics. So if you're not familiar with the aerial geophysics, what we did is we hired a company. They came down from Canada with the helicopter in this electromagnetical array that they hung from the helicopter, and they flew the coast. And first they do these perpendicular areas like this, these lines, and that gives them an idea of where the freshwater saltwater interface is. The salt water is more dense. It shows up as red. The brackish water, orange, yellow, green, and then blue is the fresh water. And then once they have an idea of where that interface is, they start flying parallel to the shoreline and gathering the data. So it's really helpful for us to know where that interface is, to see what a threat saltwater intrusion is. And then one of the kind of caveats is they can't fly over populated areas. So they did the coast and they didn't fly over the cities. And then we're also implementing or pursuing an implementation grant through Prop 1, and I'll talk about that here in a minute. So as far as financing goes, we did receive the Prop 1 grant I just shared with you. The implementation grants, the applications are due in June, July timeframe. If successful, this can fund 50% of the project, which is huge. When you look at the cities, again, Grover Beach, Arroyo Grande, Pismo Beach, were small municipalities. That would really help with getting this project over the finish line. We also received a Title 16 grant in the amount of just under $800,000. The date for the next round is not certain, but once they announce that, we will certainly apply, and this could fund an additional 25% of the total project cost. So when we look at kind of what we're doing technically, we do have the test injection well that we're working on right now. This was delayed due to appeals to the County Board of Supervisors and then to the Coastal Commission by one party who's pretty much the only one I know of that's against Central Coast Blue. And that delayed us about 3 months, which was very disheartening. Our contractor almost left. They told us they couldn't perform. They had another job lined up with another agency, and I actually have a very good relationship with that other agency. The director down there is my former boss, former director here in Pismo, and so we were able to work out a deal to allow the contractor to do our well and then go do their project. The monitoring well has been completed, the ocean outfall has been completed, and the drilling of the well has been completed, and they're currently testing the pumps and getting that all set up. And once that's done, we'll run some tests, travel time test, contact time test with that well. And also when we did the drilling, we collected soil samples and took cores. So we really are gaining a lot of information about the basin, the makeup of the basin, and how the basin will react once water is pumped into it. So we're expecting this to all be wrapped up by the end of the month. And what's being referred to as the Great Wall of Oceano, that sound wall you see in the picture, will come down. That sound wall, it's this heavy fabric, and it's really amazing. When you're inside the walls, you can't hear the traffic at all. And when you're outside the walls, you hear the traffic, but not the pumps, or not the drilling rig. It's really amazing. Looking at the lithological model, it includes 19 million cells. So this is just a snapshot of the model. I found it very interesting, the amount of data that's contained in this. And what's really amazing is just 10 years ago, in order to produce and run this model, would have taken a computer that filled a room. And now with today's computing power, they're running it with just a normal desktop computer, which blows my mind. So moving on to the looking at, so the yellow line that you see there shows proposed, these are proposed injection wells. this is where we saw saltwater intrusion. So the injection wells located here with the infrastructure to deliver it, and then our production wells. So what you see is that not only are we providing water to drink, potable water, but we're creating a saltwater intrusion barrier. And what the model showed us is that when we inject the water, a portion of that water does go to creating a saltwater intrusion barrier, and then a portion will migrate towards the wells. So I briefly talked about the advanced treatment facility. You can see here, City of Pismo Beach treatment train. We have our bar screen, secondary treatment, clarifier, and then it gets chlorinized, dechlorinized, and just discharged to the ocean. We're adding microfiltration, reverse osmosis, and then there's a brine that comes out of that that'll be discharged to the ocean, and then the advanced oxidation, and then we inject the water. We were very fortunate. We partnered with IDE, Israeli desal engineers. They provided us with a pilot plant. They wanted to get some data, and we wanted to get some data, so we partnered. We provided the site and the effluent and the operators, and they provided the equipment. You can see this is the pilot plant here, and here you can see Congressman Carbajal touring it. Paul provided the microfiltration, IDE, the reverse osmosis. And what was really amazing is if you have an RO system under your sink, this is the exact same technology, just on a grander scale. And then APWA provided the UV advanced oxidation. And we did tours. We invited the public to come and tour and taste the water. And what we did is we had 2 cups, we labeled them A and B, and one was filled with tap water from the City of Pismo, and one was filled with plant water or recycled water. And we had folks taste them, and then we took a poll. How many people thought cup A tasted better, and how many people thought cup B tasted better? And about 70% of the people who tasted the water thought the recycled water tasted better, which was really interesting. So the pilot plant really helped us with acceptance. The demonstration facility promoted regional stakeholder engagement. It really allowed us to performance test the equipment that we want to use, and really promoted innovation and refining design. And it really helped us not only gather a bunch of data, but analyze our proposed design and make operational improvements to that design. So the project that we're going to build isn't what we originally thought we were going to build. We did some tweaking thanks to the pilot plant. And one of the big things that came out of the pilot plant is we thought we were going to have to mix the brine solution with potable water to meet our discharge permit. And what we found is that we analyzed the brine, and it meets the city's NPDES permit. And we were really happy to find that out, that we don't need to dilute it, and that it is safe to discharge directly through the outfall. So we have purchased a parcel, a 1 3/4 acre parcel in the city of Grover Beach that's located right here on Hubner Street. Here you can see 1 is the City of Pismo Beach treatment plant, 2 is the district's treatment plant, and then this is the parcel that we bought. So our ocean outfall line runs down right through here. It's this blue line, and the parcel that we purchased is right there, just sort of adjacent to the line. And so what we'll do is we will cut our outfall line and divert it. We'll bore under the railroad, divert it to this site, and then we'll have a line that goes back to the ocean outfall to discharge the brine. So it'll really help on infrastructure implementation costs, because the outfall is already there. And then we'll just have to build the distribution system to get the water to the injection wells. As far as governance and cost sharing go, we prepared a draft MOA that was approved by all the agencies. A final MOA that we're now calling an operating agreement has been distributed to the agencies. Our city council will consider that this evening. And should they authorize it, our city manager will sign it. Grover Beach will consider it on the 22nd, and Aurora Grande on the 23rd. So those are really some huge milestones. We did recently certify the EIR, which is another huge milestone. But looking at the timeline for Central Coast Blue, 50% design we're hoping to have completed by winter of this year. We're working on funding and financing now through 2023. The EIR has been certified. We're currently working on our land use permits with the city of Grover and hope to have that wrapped up by the summer of next year. Our regulatory agency permits, we're hoping to have that wrapped up by the beginning of 23. Final design, we're looking to start that early 22 and wrap that up in the spring of 2023, and hoping to be in bid spring to summer of 23 and start construction in summer, fall of 23 and wrap it up in 24 and be one step closer to water independence. So that concludes my presentation. I'm more than happy to answer questions on any part of it if you have any. And if not, that either means that I did a really good job or a really bad job and you didn't even get enough information to formulate a question.
Thank you, Ben. If anybody wants to ask a question, go ahead and just turn on your mic and ask a question.
If I was smart, I would have planted a couple questions.
Definitely. All right, I think this is the end of this presentation. Ben, I can't thank you enough. I enjoyed working with you on getting this thing prepared. I was just amazed at the amount of information that you covered and the amount of knowledge you have in the world of water in the city of Pismo Beach. Obviously, you have a very strong interest and knowledge in this area. Leroy, are you there?
Yes, I am here.
Do we have a raffle prize to give out?
We do. We had a little bit of technical, I'm having technical difficulty. Let me just check one thing. Okay, so I will do the raffle, the prize. Let's see if I can share my screen here. You guys see the wheel?
We can see the wheel.
Okay. This will be my first time. We're going for a $25 gift card here. There we go.
We don't get the Glade Plus.
No.
Okay, just so we're sure.
Wow. So somebody signed in with a phone number. There we go.
Leroy Cadena has won.
Oh, no, I think it was, no, that's not right. Let's redo that.
Okay.
I'm not going to take it. Let me take my name. Let's see.
Just let it spin. The chances of you getting it again are not very good.
If it is, it must be rigged, right?
That's it.
Like this. Carson Woolert.
Congratulations, Carson.
Awesome.
So, Carson, what are you going to do with the gift card?
Bring in snacks for my team.
Okay, good answer.
Carson, if you could email me your contact information, or somebody with the Steve or myself or Amy Snyder. My email is
Amy's got my contact information. I've been in adult communication with her on previous projects.
All right, awesome.
Perfect. Perfect. Amy, would you like to say anything?
She was having some technical difficulties.
Okay. All right. With that, if there's no other comments, questions, or concerns, Amy says thank you. Ben and Carson, I'll reach out, and having issues with my connection right now. So Amy says she's alive and well, and she's going to reach out to you, Carson. So with that,
Oh, I should point out, Steve,
Yes.
we did record this, and so we should have a link to it on our website.
Thank you. And everybody remember the next meeting is April 1st. There's going to be a award ceremony during lunch on April 1st. So look forward to that, and the link will go out. And once again, thank you, Ben Fine. Everybody, talk to you later.
How do I stop sharing?